All right, in the last section, when we graphed those lines in section 2.1, we saw that the lines went in all different directions, okay? And so the question then becomes, is there a way to describe how slanted a line is? If it's getting big real fast or real slow, or if it's getting smaller, is there some way that I can measure the slant of a line? And if you've been in any sort of algebra and dealt with lines, you know what's coming up. So just bear with me, because I don't make assumptions in here. Just want to make sure that I'm giving everybody all the detail they need. I'm just going to show you where the origin of this measurement is and where it comes from. So what I'm going to do on this Cartesian plane that I have right here is I'm just going to pick any 2 points. These points, I'm just going to separate them so they're spread out, but there's nothing special about these points. So I'm going to pick this point right here. I mean, that is the point 5, 7, but instead of that, because the point doesn't matter, I'm going to call this point x with a little 1, y with a little 1. That's my first point. That is not an exponent. Those little ones, those are distinguishing that is the first point that I'm going to be using. So then far away, just so I have enough room, down here in quadrant 3, I'm going to do the same thing. I'm going to make a dot right here. Again, it's -5, -6, but that's not important. I'm going to label it very generally as this: x with a little 2, y with a little 2. And again, those aren't exponents. That's just saying I've got a first point and I've got a second point, okay, to distinguish instead of using different letters. And so I'm going to connect the dots. And here's what I want to know, and here's basically the thing we are going to repeat over and over and over and over again today is there a way to measure how slanted this line is? Well, I can't just count the spaces, okay, because this graph doesn't go through every place where the vertical and the horizontal lines meet. So I need a way that I can do some counting. So here's what we're going to do. Instead of worrying about how far I'm going from here to here, I'm going to break this up into the horizontal direction and the vertical direction, because I can count those spaces. Okay, so I'm going to make a nice dotted line. I'm making a little triangle here, dot, 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 and then here, dot, 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 there we go. And the reason that I do this, again, just to reiterate, is because when I'm going horizontally and vertically, I can count the spaces, 1, 2, 3, 4, to be able to count how far horizontally, how far vertically. Now, I know probably most, if not all of you, have seen this before. So some teacher at some point has said that the measure of the slant of the line, which we're going to call slope, is what divided by what? It's rise over run. So this vertical distance, this vertical change between the points, is called the rise. Okay. That's how far, like if you're climbing a mountain, that's the elevation change from the bottom of the mountain to the top. Doesn't mean that's how far you're walking. It means that's how far up above sea level you have now gone. That's called the rise. And what I can do now, this becomes a fairly simple doesn't always mean easy, but it's a fairly simple calculation. To find the rise, all I'm going to do is I'm going to take the difference between the y values. So I'm going to take y1 minus y2. Now, I know somebody in here is thinking the following question. Probably a bunch of you are. Hey, Perkster, why did you do y1 minus y2? Why didn't you do y2 minus y1? And that's a great question. And the answer is going to be, it doesn't matter. Okay, and I'll show you that in a minute. Okay, but just bear with me for a moment. Then this right here, my horizontal distance, how far left or right I've gone as I've climbed up this, as I've climbed from one point to the other. This is called the run. That is my horizontal distance that I've gone. Now you help me, because I don't want you to fall asleep here. If I calculated the vertical distance by taking y1 minus y2, what do you think I'm going to do to calculate the horizontal distance? Yeah, perfect. Said with boldness. I love it. We're going to take x1 minus x2. And now that I've calculated how far up I've gone and how far left and right I've gone, we use those two measurements to create a ratio, and that's called the slope. So over here on the right side of our page, the slope. For the slope, we use the letter m I don't know why, probably has something to do with Latin. The slope m of the line passing through the distinct points x1, y1 and x2, y2 is defined in the following way. You already told me it's the rise over the run. We didn't make this up. Some mathematician many centuries ago made this up. We have inherited this. Okay, so this is just, we have to learn this. It's the ratio, the rise over the run. And so what we'll do is we'll take that distance we've gone vertically, y1 minus y2, and we'll divide it by the distance we've gone horizontally, which is x1 minus x2. Now, to answer that question, hey, Perkster, does it matter which direction I go with my y's and my x's? The answer is no, but you have to be consistent. Whatever point is your first and your second point, you have to go in that order. So if you would have said, if you would have used this point down here at the bottom and said y2 minus y1, then what do you think you would have to do with the x's? Yeah, same order, x2 minus x1. It doesn't matter which order you choose. You just have to be consistent. Okay, now let's just go ahead and put some numbers to this. So for the next few problems, we are just going to practice finding the slope. Has everyone got this written down? Can I slide my page up? You doing okay? Let me know. I don't want to rush anybody. So I'm sliding. Here we go. My example one. We are going to calculate the slope of the line that goes through these 2 points, -1, -7, and 3, 4. All right, here we go. Slope m is the rise. Somebody give me the difference that we are going to use to calculate the rise. Okay, which one do you want to be y1? Okay, there we go. -7 minus 4. So if you were a y1 is -7 and you did -7 minus 4, then what does your run have to be? What do you have to subtract? -1 minus 3. My y's were -7 minus 4. My x's were then -1 minus 3. And here's what I get with my arithmetic. Your calculator will tell you -7 minus 4 is -11. -1 minus 3 is -4. And a -11 divided by a -4, a negative divided by a negative is always a positive, so we get 11 over 4. Now, before we talk about slope and what that's communicating to us, this is the only problem. I'm going to do this both ways, but I just want to prove to you I'm not lying to you, because I know you're still building trust with me, and because I'm a math teacher. So you could have done this. Okay, you could have said, you don't have to write this down if you don't want to. I'm just showing you that it would work and get the same thing both ways. If you would have said, my difference between my y's is 4 minus -7, okay, so 4 minus -7, then what's the corresponding difference between the x's I would have to use? Perfect, well said, 3 minus -1, yes. And when I subtract a negative, 4 minus -7, what's subtracting a negative the equivalent to? Adding. So that's 4 plus 7, that's 11 in the top. That's 3 plus 1, that's 4 in the bottom. And notice I got the same exact value regardless of which point was my first point, which point was my second point. Either way, the slope is 11 over 4. So help me, because this is the part that matters. The 11 is telling me my line goes 11 units which way? The y direction. So up, positive 11 is up 11. And then 4 units which way? The positive x direction, which is right. So we would go right 4. And your line will never change that ratio. Okay, the slope of a line never ever changes. All right, try this one right next door. Exercise 1. Calculate the slope of the line through 3, 2 and -5, 5. right, so my slope, my m. I'm just going to do the rise, the difference between the y's, according to what the first thing I hear is. Somebody tell me what the difference between the y's is, or how you calculated it. Okay, well, how'd you do that? What'd you? Perfect. That's what I wanted. Thank you. Sorry, my question was not clear. 2 minus 5. Yes. So she used 2 as the first y, 5 minus the second. If you did the reverse, remember, you're going to get the exact same thing I get. Okay. So since she used 2 minus 5, what's the difference between the x's we have to use here? 3 minus negative 5 for sure. So if you did it this way, 2 minus 5 is negative 3. 3 minus a negative 5, that's 3 plus 5, that's 8. And so the slope is negative 3 over 8. Now, if you did it the other way, you got 3 over negative 8. That's fine. It's the same thing. A positive divided by a negative or a negative divided by a positive are both negative numbers. Okay, so it's equivalent. Okay. You tracking with me? Questions, comments, concerns? I'm having a great time. I want you to have a great time too. All right. Slide down the page, exercise 2, same thing. Calculate the slope of that line. So somebody tell me how we are going to calculate the rise of this. Sounds great. Negative 6 minus 4. Again, I'm just using the same, the first thing that I heard. If you did 4 minus negative 6, go with it. But since I heard negative 6 minus 4, what is my difference between my x's I have to use? Negative 4 minus 3. Have to be consistent. You have no choice in that. So negative 6 minus 4 more is negative 10. Negative 4 minus 3, that's negative 7. And a negative divided by a negative is a positive 10 over 7. We doing okay with the arithmetic? All right. Well, then the next thing I'm going to do is I'm going to absolutely astound you with an amazing demonstration. Okay, so I want to tie this together with what we were talking about last time, which is linear equations and graphing lines and being able to understand what the picture is communicating to you. So this amazing demonstration says by finding 2 points, so we're going to find 2 points like we did in class last time, we are going to find the slope of the following line. So notice it's a linear equation. There's an x term, there's a y term. The only thing I've done on this linear equation is I've set the y by itself for a specific reason. And again, if you've seen lines before, you know what's coming. Sorry that this is not more invigorating. But we're going to find 2 points. So I'm going to make a little table over here. And I'm going to declare the first x value we're going to plug in is 0. It's my favorite x value, so 0 times anything is 0, as we saw when we were doing our intercepts earlier before we started the video. Somebody tell me, what's your favorite x value to plug in? Okay, 0. I've already done it. We need a different x value. That's on me. You said 1, right? Okay, so 1. There is no wrong answer. If you used 1 or 2 or 155, it would not matter. You would get the same result in this demonstration. Here goes. When I plug 0 in for x, what's 5 times 0? 0. What's 0 plus 3? 3. So my result is 3. I'm just not writing it down because I don't have a lot of room there. Does anyone not see where that number 3 came from? Are we okay? When I plug 1 in, what's 5 times 1? 5 plus 3 is 8. Okay. There's my 2 points. And so now what I'm going to do is I'm going to use these 2 points just like we did a few minutes ago, and I'm going to find the slope. So here goes. M is my difference between the y values. I'm just going to go up the ladder here, and I'm going to say 8 minus 3. The difference between my x values. Again, I'm going to go up the ladder here, and that is 1 minus 0. Have I lost anybody? We doing okay? All I'm doing is the specific instance of finding the slope of this line by using the skill we just determined, which was finding 2 points and subtracting. So 8 minus 3, that's 5. 1 minus 0 is 1, and I get a slope of 5. So here's my big question. Your astuteness here. Do you see the number 5 in the equation we started out with? Yeah, where is it? It's right in front of the x, right here. That is not coincidence. That number in front of the x, that is the slope, m. Now, something we get for free because I like to plug 0 in. This is a review question. In fact, the answer's on the board. When I plug in 0 for x, what specific point does that give me? The y-intercept, yes. X equals 0 is your y-intercept. So this number right here, this plus 3, that is my y-intercept. And so what I have presented to you, whether or not you're breathless from the amazingness of the demonstration or not, but what I've just shown you is this. When a linear equation with 2 variables is solved for y, that is a super important part of this, has to be solved for y. When a linear equation in 2 variables is solved for y, you have what's called the slope-intercept equation. Math people are not super creative when we label things. Okay, so you can see it's called the slope-intercept equation because it tells you the slope and the intercept. And it's generalized in the following format, which you probably remember again if you've had any sort of algebra. It's y is equal to mx, the slope is always in front of the x, and then for whatever reason, math people, they get pretty specific. Math people use the letter b for the y-intercept. I don't know why, but we'll go ahead and follow the convention. Y equals mx plus b. M is the slope, b is the y-intercept. Everybody caught up? Can I flip the page? All right, I'm doing it. So the next few problems, we are just going to practice finding the slope and the y-intercept and using that information. So example 2 at the top of the page is my example. And it says, find the slope, y-intercept, and then graph this linear equation. And it's y equals 2/3 x minus 5. What's the slope? 2/3. The slope is always the number in front of the x. So 2/3. What's the y-intercept of this line? -5. I'm going to write that as a point because it's a point. 0, -5. All right, now let's graph. So what I'm going to do is I'm going to plot this point as 0, -5. So I'm going to go down 5. I'm going to make a nice dot right there. And then we're just going to use this ratio. We're just going to do some counting. So again, I'm just helping you review. I'm hoping some of this will stick into your long-term memory. What does the 2 represent? The y direction. And yes, it's positive. So we're going up. So we're going to go up 2. And then what does the 3 represent? The positive x direction. So we're going to go right. Okay, rise over run. So here we go. I'm going to go up 2, right 3. I think this is super relaxing. I can almost not stop. Up 2, right 3. And then I'm going to make a dot. And then I'm going to do it again. Up 2, right 3. Make a dot. I'm having so much fun. I'm going to do it one more time. Up 2, then right 3. And there we go. There's my dots. I recommend doing at least 2 extra dots. So like 3 total, just so it's easy to miscount on these things. And I'd hate for you to get the problem wrong on the test because you miscounted. Put some arrows on the end, and there's my line. Anyone not see how we came up with that? Well, you get your chance to prove it. Exercise 3, right below. Different line. Y equals 4/3 x plus 2. I would like you, please, to do the same thing. What you write down for the slope? 4/3. By the way, just as an aside, if you're writing an x there, the x is not part of the slope. Okay, there's no variable in the slope. The slope is a constant. So if you're writing the x, erase it. Okay, there is a deduction for that because the slope is just 4/3. It is not 4/3 x. And then the y-intercept is 0, 2. Great job. So I'm going to plot that point 0, 2 right there. And then tell me, because this is the new learning for the day, the 4 represents what direction? My y direction, and yes, it's positive, so I go up. The 3 represents what direction? The denominator of the fraction is my run, my left and right. And since that's a positive 3, I go right 3. So we're going to go 4 up, 1, 2, 3, 4, and then right 3. 1, 2, 3. I'm going to do it again. 1, 2, 3, 4 up, 1, 2, 3 to the right. And there's my dots. They all seem to be in line. So, boom, there it is. So far, so good? Top of the next column, exercise 4. Here's what I want you to do. I'm going to give you 20 seconds. Write down what the slope and the y-intercept is. If you're familiar with this and want to graph, go ahead, but I'm going to mention something about this one. What's the slope of this line? -1/4. That negative is part of the slope. We're going to talk about that in a minute. What's the y-intercept of this? 0, -3. Great. Now, the reason I asked you to pause on graphing it is because the question always arises, what do I do with that negative? Where do I put it when I'm graphing? Well, you have a choice, okay? Because I have a negative value. So you get a negative value by either having a negative divided by a positive or a positive divided by a negative. It doesn't matter which. So what I mean is you could put the 1 with the negative with the 1 in the top and have -1/4. In that case, if you had the 1 as negative, which way are you going for -1? Down and then 4 to the right. Or you could do 1/4. It's all going to be the same line. It doesn't matter which way you do that. Okay? I'll show you on this one. I'll do both. So my y-intercept is -3, so down 3. If you are someone who would have put the negative with the 1, then you just told me we're going to go down 1 and then +4. 1, 2, 3, 4. Down 1, +4. 1, 2, 3, 4. And you could do it over and over again. If you are somebody who would have put the negative with the 4, then what is the positive one now communicating to you? Up. And then the -4 is telling you to go left in the negative x direction. So up 1, left 4. Okay, so the signs have meaning for us. But notice whether you went up 1 and left 4 or down 1 and right 4, are they all on the same line? Yes. Okay, look, my straight edge connects them all, and there you go. Questions thus far? Don't be shy. I know that this is difficult stuff, especially if you haven't seen it before. Okay, I'm here for you. Let's go down to example 3. What's different about example 3 than the previous ones? We got to solve for y. It's in standard form. It's not in the right format. Great answers. Appreciate you guys for answering for me. So this is standard form. We talked about standard form in the last section. Standard form is really good for when I need to find my x-intercept and y-intercept, but it's not good when I need to find my slope. So I'm going to solve this for y. So if you haven't solved an equation with 2 variables for y, okay, if this is going to be new, rest assured, it's the same 2 steps every time. The steps do not vary. Step 1. If I'm going to solve this for y, I've got to get this y term right here by itself. So what do I have to move to get the y term by itself? The 2x. And yes, you're exactly right. I'm going to add it. So let me come over here. I'm going to write my work. -2x plus 4y equals 16. And now we're ready to rumble. So I'm going to add 2x to both sides. And what I'm left with on the left is 4y. What I'm left with on the right is 2x plus 16. We good so far? That's always going to be your first step. Move that x term to the other side. Now, I've got the 4y by itself. If I want to get the y all by itself, what do I have to move now? I got to move the 4, and I'm going to do that by dividing because I have 4 times y. The opposite of multiplying by 4 is dividing by 4. So on the left, 4y divided by 4, those 4's cancel, and I get y. Now, here's the thing. I'm going to be completely upfront with you. I've taught this class hundreds of times. Students in general don't have a problem doing this, but here's the one mistake you sometimes make. So listen right now so that I don't want you to make this mistake. I'm dividing this whole right side by 4. Division is distributive, just like multiplication is. Okay, so what I mean by that is this 4 gets distributed to both terms in the top. Now I'm going to write this next step down. I know that you probably don't need this step, but I just want your notes to be complete. So what I mean is I've got 2 over 4 times x plus 16 over 4. I've taken that 4 and I've distributed it. And I am sure all of you here are capable of doing these two things at once. You don't have to separate these steps. Now I'm going to reduce these fractions. 2 over 4, both of those numbers are even. So 2 over 4 reduces to 1/2 x. And then 16 over 4, your calculator will tell you that's plus 4. And now we can do the same old thing we were doing before. What's the slope of this line right here? The slope. You're a step ahead of me. I know I'm sorry, I'm moving slow. Okay, 1/2, and then yes. Say it again for everybody. What's the y-intercept? 4. 0 and 4 is that point, yes, for sure. So I do my y-intercept, 0, 4. The slope is 1/2. They're both positive, so that's up 1, right 2, positive y direction, positive x direction. So up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. It's super relaxing. And connect the dots. Yeah, sure. Multiplying what by 0? Okay, so don't confuse the process of finding the intercepts that we did last time. If I wanted to find the intercepts, I could plug in 0 for y and get the x-intercept, and I could plug in 0 for x and get the y-intercept. So that gives me, yes, that would give me these 2 points. It's a different way to graph, but this way will work whether or not those intercepts work out to be integers or decimals or whatever. So that's why we're learning this way to graph. So we understand this rate of change that the line is going through. Okay, so we're doing something a little bit different. Okay, good question. All right, flip the page. At the top of the next page, exercise 5. Do what I just did with that problem right there. Solve that equation for y, and then find the slope, find the y-intercept. If you need something, raise your hand. I will come to you. I will do my best in the time we have to answer whatever questions I can. Yes, there you go. Better. All right, so I'm going to get started on this. Again, I'm not trying to make anybody feel rushed. I just try to split the difference on these things. So I've got x plus 3y equals 9. So somebody tell me, how am I going to move the x? What do I have to do? Subtract it. Yes, always the same two steps. Move that x by either adding or subtracting, and then you're going to divide. So now I've got 3y is negative x plus 9. Now what am I going to do to both sides? Divide by 3. Here was a great question that I was just asked. I'm anticipating I would have addressed this anyway. What's the number in front of the x right now, even though we don't write it? A 1. So what I have is I have a negative 1 over 3 in front of my x, my x variable, and then 9 divided by 3 is plus 3. So if you just wrote negative x over 3, that is perfectly wonderful and legitimate, and I'd give you 100% credit on the test. I'm just writing it like this so that it's really, really clear what the slope is. Which is what? What is the slope? Yep, negative 1 over 3. I'm going to leave the negative with the 1. You could also put the negative with the 3. It does not matter. One or the other. What's the y-intercept? 0, 3. And now my y-intercept is 0, 3. So I'm going to make a nice bold dot right here at 3. The negative 1 over 3 means I'm going to go down 1. That's what the negative 1 tells me. Negative in the y direction. And then the positive 3 tells me to go 3 to the right. Positive x direction. Down 1, right 3. Down 1, right 3. If you put the negative, if you did this, if you did 1 over negative 3, then you went up 1, left 3. Okay, it's equivalent. It doesn't matter. You don't have to do both. I'm just mentioning it because we're just learning, and I don't want anybody to leave here thinking, what do I do with that negative? There we go. If you got a question, please be sure to ask me. I'll come around to you like I just did with a couple students. In the meantime, slide down. Exercise 6 is the next one. Find the slope, the y-intercept, graph. All right, here goes. So my equation is negative 4x plus y equals 6. The first step, always, every time, every day, we're going to do one more of these, is to move the x term first. What am I going to do on this one to move that x term? I'm going to add the 4x for sure. It's great. And I'm left with y equals 4x plus 6. So here's what I know. Is there a number in front of the y to divide by? Well, it's 1. 1 divided by 1. So yeah, there is a number. So bad question by the Perkster. But I don't need to divide by anything. The y is now by itself. Okay, so this one actually had one less step than the other ones. So now what is the slope of this line right here? 4, which I'm going to write as 4 over 1. Well done, because we do need a rise and a run, so that's great. And then what's the y-intercept? 0, 6. So I'll go up to 0, 6. So make a dot right here, and then my slope is 4 over 1. That's 4 in the y, 1 in the x. So 1, 2, 3, 4 in the y, 1 in the x. I'm out of room on my graph. That's why I made this example, just in case this happens to you. I always like to get 3 points, just so I know. So instead of going up and right, what else could I do? Yeah, 2 negatives make a positive, right? So I could go down 1, 2, 3, 4, and then left, negative in both directions. And that gives me my 3rd point, just so that I can recognize I've counted properly. You could also use a bigger graph if you wanted. If you had some available to you, that is fine. All right, one more of these. Top of the next column, exercise 7, please. Solve for y, slope, y-intercept, graph. Yes. All right, let's see how you did. I've got to move the x term first. That's always my first step. So I'm going to subtract, in this case, negative 5x on both sides. So that leaves me negative 2y and then negative 5x plus 10. So far, so good. Anybody got a concern yet? What am I going to divide by on this one? Negative 2, whatever's in front of the y, you divide by. And then don't forget to distribute. Most common mistake. So a negative 5 divided by negative 2 reduces to 5 over 2x. A negative divided by a negative is positive. And then 10 divided by negative 2 is negative 5. Slope, 5 over 2. Y-intercept, 0, negative 5. And here we go. Negative 5 is my y-intercept. The slope is 5 over 2. So that's 5 in the y direction, 2 in the x, make a dot. 5 in the y, 2 in the x, make a dot. That's 3 lovely dots right there. So now I'm going to connect them, and there's my line. Now we're going to continue practicing this idea of graphing and this idea of finding slope in a few different situations. We've got 3 quick things to wrap up here before you're done with me for the end of week 2. Look at example 4. Example 4 is going to have us graph. We got a little less work to do here, but the information's different. Notice in example 4, it says graph the line with slope 3/5. So we're given a slope. But this time, instead of using the y-intercept, we're told the graph goes through the point -2, -4. So my process here is no different than what I was just doing. I'm going to start with this point, -2, -4. So let's make a dot there. -2 is back 2 and then down 4. So I'm making a dot. And now we're just going to use the slope of 3/5 from there instead of from the y-intercept. So again, humor me. I know you're bored with my questions. Just trying to help you learn. The 3 represents what direction? My rise, I'm going to go up. The 5 represents my run, which is going to be right because it's positive. So I'm going to go up 3, 1, 2, 3, 1, 2, 3, 4, 5, make a dot. And then 1, 2, 3 up, and then 1, 2, 3, 4, 5, make a dot. And there are my dots. And I'm going to connect them, and that's lovely. Flip the page. I think I've got 2 problems just like that for you. They should go by pretty quickly. I'm going to give you about 30 or 40 seconds for exercise 8 at the top. Graph the line that has the slope -5/2 and goes through the point 4, 2. First thing I'm going to do is I'm going to make a dot at 4, 2. So over 4 and then up 2. So right there in quadrant 1. And then the slope is -5/2. So again, here as before, you have a choice. You can put the negative with the 5 over +2, or you can do a +5 over -2. Makes absolutely no difference. If you did the negative with the 5, that means you're going down 5, 1, 2, 3, 4, 5, and then right 2. Down 5, 1, 2, 3, 4, 5, then right 2. I'm not going to make the dots, but if you did the two negative, then you went up and you went left. Okay, all on the same graph though, no difference. Any qualms with graphing when you're given the slope and a point, whether it's the y-intercept or another point? One more, and we're about done with that. And then 2 more things to wrap up our day. All right, so this one, the point is 5, 0. So remember, my ordered pair is always the x value first, then the y value. So 5 is the x direction, and then 0 is the y. So that's an x-intercept. And then my slope is -2. So again, a negative slope, I've got a choice. I'm going to use -2/1. Or you could do 2/-1. Doesn't matter. Both of those give you -2. So -2/1 is down 2/1, down 2/1, and one more time just for fun, down 2/1. And there are my points. I'm going to connect them. There we go. All right, next thing. This is good. This helps us review and it helps us maintain things in our long-term memory. Example 5 at the top. At the end of our class last time, I gave you 2 special lines and I said, my advice to you as your math teacher is to just remember these. It makes life go a little quicker every time it comes up. So example 5, graph the following line and find its slope. Okay, what is the graph of y equal to 4? What kind of line is that? It's horizontal. It's the y value is 4 every time. So that's a horizontal line. Just to refresh your memory, I know it's been 48 hours. Horizontal line. So I'm going to draw a horizontal line at y equals 4. By the way, on the test that you have, I'm going to ask you to graph a horizontal and vertical line. It's going to happen. So might as well just remember, that way you get nice, easy, free points. Now here's the big question though, since we're talking about slope, is what's the slope of this line? Well, we said earlier that slope is the ratio of what 2 things? It's what over what? Rise over run. I'm going to write that down. And we're going to use this to deduce what my slope is. As I'm walking along my horizontal line, okay, if I'm walking along, if this is a sidewalk, how much am I rising as I walk? 0. I'm not going up or down at all. Does that make sense? Does everyone see that? We are not moving up or down. That's why it's a horizontal line. It's strictly going left and right. So my rise is 0. It doesn't matter what my run is. If you have 0 in the top, divide by anything. Let's say 10. If you have $0 and you're going to divide among 10 friends, how much are you giving each of them? 0. You have nothing to give. So there we go, 0. So a horizontal line has a slope, an m, of 0. It's not rising at all. Well, that takes a little mystery out of this second one. Is everyone caught up? I don't want to get ahead of anyone. Can I slide my page up? Yeah, it doesn't matter how far, like the reason I say the run doesn't matter is it doesn't matter if I run 2 units or 100 units. It's not going to change. 0 divided by whatever number you run is going to be 0. Okay. Great question. Good to get clarity. All right, I'm going to slide up. Same thing. This time, though, I want to graph the line x equals -3. What kind of line is it when you have x equal to a number? It's vertical. It's always a vertical line. It's a vertical line at the x value -3, so I'm just going to go ahead and do that. So here it is. Now, we just mentioned this. I'm not going to make you tell me again. The slope is equal to rise over run. This time I want us to look at the run of the vertical line, how much it's running. As I trace my pen along this vertical line, how much is it moving left and right? 0. The run is 0 on a vertical line. A vertical line is all rise, no run. So it doesn't matter what the rise is. It doesn't matter if it's 2 units or a billion units. Okay, rise divided by 0. Now here is where I need to mention something because I know I'm expecting it. So if you get this wrong, don't worry. Nothing wrong with you. Almost everyone in my last class answered this question wrong. If you have a number like 10 divided by 0, what does that equal to? Okay, no. But I was expecting it. Don't worry. It's not 0. Let me show you a little demonstration. I'm filled with amazing demonstrations today. There is a difference between 0 divided by 5 and 5 divided by 0. 0 divided by 5 is the situation. You have $0. You're dividing it among 5 friends. And you already told me that's 0. But let's do long division. I'm going to take 0 and I'm going to divide it by 5. I know it's been a long time. It's been middle school since long division, right? What number up here at the top times 5 is going to give me 0? 0, yeah. 0 times 5 is 0. Perfect. We did that for horizontal slope. There's no new information there. Here's the question that you all just answered incorrectly, and I just want to make sure we get it into our brain. This is an important math concept going from here. When you get to college algebra and we're together and we're talking about graphs of things that are fractions, this is going to come into play. You're going to have to remember this bit of information. If I have 5 divided by 0, so I'm going to take 5 and I'm going to do long division. I'm going to divide it by 0. What number up here times 0 gives me 5? What's 5 times 0? 0. What's anything? What's any number that I put up here times 0 going to give me? 0, right? So is there any number, to ask the question a different way, is there any number that I can put up here that times 0 is going to give me 5? No, everything's going to give me 0. So there's no such number. Again, to reiterate, the reason there's no such number is any number you put up at the top, when you multiply by 0, is going to give you 0. It's never going to be 5. It's always going to be 0. So there's no such number. So in math people say that when you have a 0 in the denominator, that is undefined. If you plug that into your calculator, if you put 10 divided by 0, your calculator is going to give you an error. Doesn't know what you're talking about. And so what we say as far as the slope of a vertical line, we say that a vertical line, because it's undefined, no such number exists, we say that there is no slope. No slope is different than a slope of 0. Okay, I understand that that's a little tricky. 0 is a number that exists. Okay, so a horizontal line has a slope of 0. 0 is a thing. A vertical line has no slope. It doesn't exist. It doesn't have a value. That's the difference between those two things. Okay, so you're going to have a bunch of questions on my math lab to help you distinguish between those two things. Last thing to do, flip the page. I appreciate your endurance. You all have done great today. The last thing is just another type of problem just to help us find the slope. There's really nothing super interesting here except that it's just more practice finding the slope. So if you have two non-vertical lines with the same slope, two lines with the same slope are called parallel lines. Like train tracks are hopefully parallel lines. Parallel lines never get closer or farther apart. They never touch each other. They're always the same distance apart. But the only thing you need to remember is the word parallel means the slopes are the same. Now, two non-vertical lines that are what's called perpendicular. That's a fun math word. In case you don't know what the word perpendicular means, okay, because I understand you might never heard that word. Perpendicular is like the floor and the wall. They meet at a 90-degree angle, hopefully. Okay, so perpendicular is like this, a 90-degree angle. That's what perpendicular is. And perpendicular lines have slopes that are negative, meaning they have different signs. Reciprocals. Another fun math word. And again, I'm not assuming you know what the word reciprocal is or remember it from middle school. Okay, so I'm going to give a couple examples here in just a moment once everybody gets caught up writing these things down. So if two lines have the same slope, they're parallel. If two lines are perpendicular, their slopes are negative reciprocals. So here we go. Here's a slope. Let's say, this is just examples. If I have a slope of a line is 2/5, the negative reciprocal. Well, first, if my number starts out positive, what's the negative going to be? Negative, yes. Kind of a goofy question. Negative. And then what the word reciprocal means, it's just the fancy math word for flip it. So instead of 2/5, the reciprocal is 5/2. The negative refers to the sign, the reciprocal refers to the fraction, flip it. So I'm just going to write down two more numbers real quick, and I just want you to write down what you think the negative reciprocals are. So the first one is negative 7/4, and the second one is 1/6. excuse me, what are the negative reciprocals of those numbers? All right, so -7/4. What's the negative going to do to that number? Make it, I don't ordinarily do this, but just for your notes, I'm going to write positive. And then what's the reciprocal part of this? 4/7. So positive 4/7 is the negative reciprocal. Negative means change the sign. Reciprocal means change the position. 1/6. What's the negative part of this going to be? Negative. And then what's the reciprocal? 6/1 or just 6. Okay, great. And that takes us to each of our very last problem. In the last two problems, we're given two lines. And the question is this: are they parallel? Meaning, do they have the same slopes? Are they perpendicular? Meaning the slopes are negative reciprocals? Or are they neither? Is there no relationship? So for instance, example 7, I'm going to do the first part of it. 2x plus y is 4. I know it's been a few minutes. What do I have to do to solve this for y? Subtract the 2x. And I get y is equal to negative 2x plus 4. What's the slope of that line? Okay. Okay, no x, just the -2/1. Yes, that is fine. The x is not part of the slope. All right, what I would like you to do, I'm going to give you 30 seconds. I want you to solve the other one for y, and I want you to declare or determine what the slope is of that one. What's step number 1 to solve this for y? Subtract the x. It's the same 2 steps every time. So I have negative 2y is equal to negative x plus 11. I'm going to now divide everything by -2, and I'm not going to forget to distribute. So in front of my x, that's a -1 divided by -2. A negative divided by a negative is positive 1/2x. 11 divided by -2, a positive divided by a negative is -11/2. What's the slope of that line? 1/2. All right, here's the question. Are those slopes the same? Meaning, are they parallel? No. Are they negative reciprocals? Yes. If I take 1/2 and I change the sign to negative, and then I make the reciprocal, that's -2/1, which is what I have over here. So these two lines right here, they are perpendicular. All right, we got plenty of time. Gonna give you 90 seconds. Exercise 10. Solve both of those for y and determine, are they parallel, are they perpendicular, or does neither relationship hold? All right, so it's the same two steps every time. So as you're going through your homework, please get these molded into your brain, because on the test, it's going to be the same two steps every time. Okay, it doesn't vary. So for the first one on the left, I'm going to add 3x. I got to move that x term over, and that gives me y equals 3x plus 7. Nothing to divide by there. So my slope is 3. Before we do the other one, let's prepare ourselves. If I'm going to answer parallel, since this slope is 3, what would this slope have to be? If they're going to be parallel, 3. If they're going to be perpendicular, since this slope is 3, what would this one have to be? Negative 1/3. Okay, so we're looking for one of those two numbers. Let's see what happens. So let's add x to both sides on this one. And I get 3y is equal to x plus 12. I'm going to divide both sides by 3. And I get y is equal to, the number in front of the x is a 1, so I have 1 over 3x, and then 12 over 3 is 4. So the slope here is 1/3. Not parallel. Are they perpendicular? No, they're not negatives. So this one is a neither. There's no relationship between those two lines.